In our last lesson, we found our common factors and greatest common factors. Today, we're going to be looking at prime and composite numbers. Okay, and that is lesson 9-2 on page 378. You'll find more information if you're looking for a reference. But today, we're going to identify prime and composite numbers. We've talked about it in the previous lesson. Mrs. Lund shared a little bit of background with it. One of my favorite things to do is something called prime factorization. We're going to talk about that. With the number, it says tell whether the number 14 represented by the model is prime or composite. Now, when you look at these two words, prime or composite, a prime number is a number whose only factors are 1 and itself. And sometimes I'll have my students stand up if their classroom number is a prime or a composite number. So if I was within my class going to say, all right, I want all of my students whose classroom number is prime to stand up, I would have numbers like 2, and 2 is kind of special because it's the only even prime number. 2, and then 3 would stand up, 5 would stand up, 7 would stand up, 11, I have to sit here and kind of think a little bit, would stand up, 13, and so on, and we could go on. But if you look at these numbers, the only numbers that go into them are 1 in itself. Only 1 times 3 is 3. Only 1 times 5 is 5. Only 1 times 7 is 7. If you look at this number model, 14, you know that 14 can be divided into 2 groups. So you know that 14, its factors are 1 and 14. And then, because it can be split into 2 groups, it is an even number. You can say 2 times 7. So that number, 14, has to be a composite number. Okay, they're going to take a look at these. It says the model shows 2 rows of 7 squares. The squares could also be arranged in 7 rows of 2 squares. Another way of saying that is 2 times 7 is 14, and 7 times 2 is 14. Or we said that 1 times 14 is 14, or 14 times 1 is 14. Okay? So we know that it has more than 2 factors, therefore it is a composite number. It says tell whether the number 8 represented by the model is prime or composite. Well, like Mrs. Lund said in the previous lesson, if you look at factors of 8, okay, I can say 1 times 8, and it's an even number, so I know that 2 goes into it, and we know that 2 times 4 is 8. It has more than 1 in itself as a factor, therefore the whole number is composite. And that's wrong.
That is wrong.
Once in a while they make a mistake too, but we know that we're right. 19 square tables are to be placed together to form a rectangle. Is 19 a prime or a composite number? Okay, so if you look at the number 19, when you think about factors of 19, I know that 1 times 19 is 19, and as I think about other numbers that I could multiply together to get 19, I can't think of any other numbers. So we know that 19 is a prime number, and if 19 square tables are to be placed together to form a rectangle, that tells us that they have to be arranged in a way, just like one particular way. 19 of those tables would be arranged in one long line. If you have 24 tables and they're to be placed together to form a rectangle, is 24 a prime or a composite number? If we look at factors of 24, I know that 1 times 24 is 24. that the 2 is really special because 2 is the only even number that is prime, okay? So I look at 24 and I know 24 is an even number. I can say 2 times 12 is 24, so I know right away that 24 has to be composite because it's an even number. I can take 2 times something to get every even number except 2. I can also say that 4 times 6, we can list more factors, but once we have anything beyond 1 times itself, we know that the whole thing is a composite number. Oh, this is my favorite thing. Okay, so here's where this knowing what a prime number really comes in handy. When you're doing prime factorization of a number, we're going to take like 54, and we're going to put that at the top, and we call it a factor tree. And we're going to break 54 down into any 2 numbers that equal that number. Now, if I look at 54, and if I've got a bigger number, I oftentimes, and especially if it's even, I oftentimes will break that down into 2 times something. I know 54 is even, it ends in a 4, so I'm going to break that down into 2 times something. I know that 2 times 27 is 54. Here's where we stop. Then you look at these 2 factors and you say, is 2 a prime or composite number? We know it's a prime number, so I'm going to circle that because I'm going to stop with that one, okay? And then I look at 27 and I say to myself, is 27 a prime or a composite number? Well, I know that 1 times 27 is 27. I also know that 3 times 9 is 27. So I know that this is a composite number, and I'm going to break it down 1 step more. I'm going to say 3 times 9, because I know 3 times 9 is 27, okay? Then we have to ask ourselves, is 3 a prime number? Thinking about the number 3, I know that 1 times 3 is 3, and I can't think of any other factors or any other numbers that I can multiply together to get 3. So I'm going to stop right there, and then I'm going to look at my other number. Is 9 a prime or a composite number? I know that 1 times 9 is 9, but I also know that 3 times 3 is 9. So I know that 9 is a composite number, so I'm going to break that one down a little bit farther, and I'm going to write 3 times 3. Well, I know that 3 is prime, and 3 again is prime, so if I were to write this prime factorization of 54, I would say 2 times 3 times 3 times 3. And if I want to get really fancy, I could say, we know from our math minutes when we've talked about exponents, I could also say this can also be expressed as 2 times 3 to the 1, 2, 3, third power. Okay, that's how, and if I multiply, 2 times 3 is 6, times 3 is 18, times 3 is 54. If you multiplied out those prime numbers, you should get your original number if you did it correct. Okay, now let's take a look and see how they did it. Okay, they wrote their numbers, and there's oftentimes different ways that you could break these numbers down. I chose, because it was an even number, I oftentimes, like I said, will just divide it by 2, or put 2 times whatever. You could also say 3 times 18. Either way, in the end, you're going to come up with the same numbers. We said 2 times 3 times 3 times 3, and you want to list them in typically in order from smallest to largest number. So 2 times 3 times 3. Okay? Which shows a prime factorization of 81. So we're going to take 81 and we're going to break that down, okay? I'm thinking about numbers that I can multiply together to get 81, and the first one that comes to mind for me is 9 times 9, okay? So now I'm going to look at these 9s and I'm going to say, is 9 a prime or a composite number? I know that it's a composite number because 1 times 9 is 9, 3 times 3 is 9. So I'm going to break this down a little bit farther, each of them, and I know that 3 times 3 is 9, and the same over here, 3 times 3 is 9. So the prime factorization for 81 would be 3 times 3 times 3 times 3. So I'm going to look over here, and I know that that would be C. Okay? All right. Boys and girls, you can look forward to some more prime factorization and determining if a number is prime or composite in the practice that we have for you. Thank you.